I want you to imagine your cat, or maybe your friend's cat. You and your cat and everything else that exists today came about as a result of evolution. Charles Darwin, whose theory of evolution dominates our curricula today, thought of evolution as a slow, gradual process taking place over millions of years. For instance, there is at least 60 million years of evolution between you and the cat. If evolution always happens at such a slow pace, then we expect that many organisms today will be at a risk of extinction due to their inability to adapt rapidly to environmental change caused by climate change. However, there are many organisms that are able to adapt quickly, such as three-spine stickleback, which are the objects of my study. These organisms inhabit the coastal and ocean regions of the northern hemisphere. Most times, most populations can also inhabit freshwater lakes. The form of the organism in the ocean are mostly larger compared to those in the lakes. What happens is that fascinatingly, when you put the population from the ocean into a lake and you come back a few years' time, you will see that the population that you put from the ocean into the lake would have changed from this bigger form into the smaller form. In my dissertation, I want to understand the genomic basis of this rapid evolution. I do this by sequencing thousands of genomes of three-spine stickleback. What I find is that first, in as few as 2 generations after the transplant, you see that this larger form would have changed into the smaller form. But more crucially though, what I have found is that in order for this to happen, there has to be a very rare set of individuals in the ocean. And this rare set of individuals have some specific genetic materials that help them to adapt in the new environment. This means that in order for us to be able to give a chance for any organism, including you and the cat, to survive the challenge of climate change, we have to preserve all existing genetic variations. Thank you.